Question number 21 of this review is asking for finding a pH of pure water if the ionization constant of water at 25 degrees Celsius is 3.5 times 10 to negative 14. We know that for pure water, Kw is H3O times OH. So each of them is X. So 3.5 times 10 to negative 14 is equal to X squared. And then X, which is equal to H3O is going to be, it's going to be 1.87 times 10 to negative 7 molar. And since you're looking for pH, is minus log of 1.87 times 10 to negative 7, which is 6.70. So you choose answer C. Question number 22. What is the hydronium ion concentration in a solution formed by combining NaOH to HCl to give NaCl and H2O? It's not the equilibrium anymore. So you have 0.3 molar of HCl for HCl times, if you multiply it by the molarity by the volume, it would be 0.15 liter, which gives you 0.045 moles. For NaOH, you have 0.1 molar times 0.45 liters, so it's going to be 0.05 moles again. Because you have same number of moles, equal number of moles, means that you are at pH 7. Whenever you have the moles of strong acid and base at pH 7, the number of moles are going to be the same, and then the concentration of H3O and OH are going to be 10 to negative pH, which are 10 to negative 7. You will choose answer C. Question number 23. At 25 degrees Celsius, a solution has a hydroxide ion concentration of 8.22 times 10 to negative 5 molar. What is the hydronium ion concentration? We know that we're solving for hydronium ion concentration. We know that at 25 degrees Celsius, and hydronium times OH, and by the way, this is question number 23, is going to be 1 times 10 to negative 14. So concentration of H3O is 1 times 10 to negative 14 divided by 8.22 times 10 to negative 5, which will give you 1.22 times 10 to negative 10 molar. You will choose D. I'm sorry, you choose E. Question number 24. You have this solution BaOH2 giving Ba and 2H is not given, but you need to, even without writing it, you need to know that BaOH2 is going to produce 1 Ba and 2 OH. So since you're looking for the pH, you need to find the concentration of POH. If you have 0.0027 molar of this, you will have 0.0027 molar of barium, but 2 times 0.0027 molar of OH, which is 0.0054 molar of OH. That's the concentration of OH. Then you're looking for POH, then POH is minus log of 0.0054, which is 2.27. You will choose D. For question number 25, question number 25, you just need to go by the description of acid and base. Which of the following does Kc correspond to the acid dissociation of H2PO4? Acid dissociation, it should act as an acid, so water, we always add them to the water, should act as a base. Acid will donate the proton, so we'll have HPO4 -2 plus H3O. Which one of these equations show that? C, correct? For question number 26, the pH is given. pH is 4, and we need to find the degree of ionization. Degree of ionization is the amount that is ionized divided by the original value. So when pH is 4, then concentration of H3O is 10 to -4, correct? Then degree of ionization, this degree of ionization is going to be 10 to -4, the amount that you have, divided by the original value, which is going to be 10 to -2 So it's given in percentage, so I'm assuming that it's asking for the percent ionization, not the degree of ionization, because the answers are in percentage. So if it is in percentage times 100 is giving you 1%, and you choose D. Question number 27. The equilibrium hydronium ion concentration of an initially 0.655 molar solution of monoprotic weak acid is 5.5 times 10 to -3 molar. So a weak acid, again, since the beginning of this concept, I told you to use Ha plus H2O gives A negative, it's anion, plus H3O. So the concentration is 0.655 molar initially, and 0 and 0. The equilibrium hydronium ion is 5.5 times 10 to -3 molar. That's the equilibrium concentration, which is going to be the same as A, right? Because both of them have the same coefficient. So that's the X. What is the pH of the solution? So we don't need anything else except this concentration, since the concentration of H3O, we even didn't need to put the ice table because we don't need this concentration. Is 5.5 times 10 to negative 3. Then pH is going to be minus log of that concentration. It's going to be 2.26. You choose A. Question 28 is conceptual. The three acids are given: acetic acid and Ka values. Ka value for acetic acid is 1.8 times 10 to negative 5. For HOCN is 3.5 times 10 to negative 4. And HF is 6.8 times 10 to negative 4. So rank these as acids in order of increasing strength. The weakest to the strongest. Okay, the weakest will have the lowest Ka and the strongest will have the highest Ka. So which one has the lowest Ka? 1.8 times 10 to negative 5. Between these two, which one is lowest? 3.5 times 10 to negative 4. And then 6.8 times 10 to negative 4. So HF, HOCN, and HC2H3O2 acetic acid is the lowest. So seems like A is the correct answer. Question number 29 is the longest question in this review, since you need to work on a quadratic equation. What is the pH of a solution prepared by dissolving some chloroacetic acid? Again, don't worry about this long formula, just add it, HA added to water to have a negative plus hydronyl ion. That's all you need to do, don't worry about it. So it says that we have initially have 0.0163 moles and in 1.3 liters. Then Ka is given. Ka is how much? 1.4 times 10 to negative 3. Then we are supposed to find pH of the solution. So in order to find the pH of the solution, we need to find the concentration of the hydronium ion. So instead of working with moles, let's change this to the molarity and work with the molar concentrations. Then this is the initial 0 and 0. Change is going to be minus x, plus x, and plus x. Then at equilibrium we have 0.013 minus x, x, and x. So Ka, which is 1.4 times 10 to negative 3, is going to be x squared divided by 0.013 minus x. This 0.013 divided by 1.4 times 10 to negative 3 is less than 1,000, so you need to work on a quadratic equation. I just put the quadratic equation. I leave the finding x, the procedure on you. That will be your quadratic equation. Then after you solve this equation, the value for x, the accepted value for x, you will end up having two values for x. One of them is negative. The positive one is 3.62 times 10 to negative 3, which is the value for H3O, correct? So pH is going to be minus log of 3.62 times 10 to negative 3, and it's going to be 2.44. And you have it as choice B. So you get B as the correct answer. Question number 30. Question number 30 is, what is the concentration of HC2O4 in a 0.3 molar oxalic acid, H2C2O4 plus water? You can use H2O, H2A, or work with the same formula. Plus H3O. Ka is, and you know that it's going to decompose into ionize in two different steps. For Ka, for the first one, it's 5.6 times 10 to negative 2 times 10 to negative 2, and Ka2, which is this HC2O4 plus H3O, plus H2O, sorry. It's C2O4 negative 2 plus H3O. Ka2 is going to be 5.1 times 10 to negative 5. So initially we have 0.3 molar, 0, 0. During the change we have minus x plus x and plus x. So it's 0.300 minus x, x and x. So for here, I don't erase this because I want to explain something, so I keep it. So so again, you have another quadratic equation, 5.6 Ka1. 5.6 times 10 to negative 2 is x squared divided by 0.300 minus x. Then your quadratic equation form is going to be x squared plus 5.6 times 10 to negative 2x minus 1.68 times 10 to negative 2 equals to 0. Then you will find two values for x. The acceptable value for x, the positive one, is going to be 0.105 molar. Now, I kept this second ionization to tell you something. You might say, okay, I'm not done yet. I still have it here, but if you plug it in here and go with the rest of the procedure and solve it, so if you put, for example, here 0.105, then it would be minus x at the end and at the equilibrium, and then you will have x, and then you solve another quadratic equation. You will end up having a very, very small amount for this compound, which is, you can ignore it, is negligible. So you basically end up having this again because Ka2 is very, very much smaller than 1,000 times smaller than Ka1. So that's why the correct answer for 30 is 0.105, which is B. 0.105 is B, 1 times 10 to negative 1. Question number 31. 31 is asking what is the base ionization equilibrium constant for an aqueous solution of ammonia. An aqueous solution of ammonia means it's base ionization, so this is going to act as base plus water is going to, this is the base, right? So it's going to accept the proton NH4 positive plus OH. So KB is going to be NH4 times OH divided by an H3. Which one of them is showing this? A, correct? Am I right? No, I'm sorry, that's D. D shows the same equilibrium constant expression. Number 32. Number 32, which of the following equilibria best represents the hydrolysis reaction that occurs in an aqueous solution of KNO2? KNO2. In none of these reactions you saw that cation has a role. So eliminate it and then you add a negative charge to your anion. Hydrolysis means in water. So this is acting as base. So you have HNO2 plus OH, right? Which one of them is showing that? Isn't it B? So B is your correct answer. And finally, the last question, which of the following salts will produce an acidic solution when added to pure water? According to when I was explaining, I said CS2CO3 with OH divided to cation and anion. With OH, you have CSOH. This is a strong acid because it belongs to group 1. Group 1, this is a strong base, I'm sorry. The group 1 bases are strong. And with acid, with hydrogen, it's going to form the weak carbonic acid. So, weak acid. So, the total strong base is going to win, so the total solution is going to be basic. But we're looking for the acidic solution. NaF, B. NaF, again, divided. This first part always with OH. This is a strong base. And this is HF, weak acid. So again, the result is going to be basic. Then C is KCN. KCN divided again with OH is KOH, with H is HCN. This is a strong base. This is the weak acid. Again, the result is going to be basic. Al NO3 3 AlOH3 is a weak base, and this is going to be HNO3, a strong acid, so the result is going to be acidic. So this is the answer. And if you want to know the answer for Li2S, again, LiOH and H2S. This is a strong base and this is a weak acid. So the result is going to be basic. Alright, that's all for this review. Good luck with the studies for the exam. Pay attention to details and be careful about the details and all the concepts.